Assalamu alaikum. In this video, we are going to discuss about the binary search recursive method algorithm. Here is an array of 9 elements in which 2, 4, 9, 12, 15, 20, 25, 28, 30 are the elements of an array. The 0 is an lower bound and 8 is an upper bound. Let's start the algorithm. Begin. First, we create a function in which we receive lower bound, upper bound, and the key value. We created a function in which we receive lower bound, upper bound, and key value. Then we check if lower bound is equal to upper bound. Then we created a condition the lower bound is equal to upper bound. Then we check the value at lower bound is equal to key value. Then return lower bound. Else return 0. If lower bound is not equal to upper bound, then we store lower bound plus upper bound divide by 2 in mid and check mid is equal to key, then return mid. Let's check. Here you see mid is equal to lower plus upper divided by 2, and we check if key is equal to mid value, then return mid. If key is less than mid value, then we calling the binary search recursive function. On left hand side we pass lower bound and we pass mid minus 1 to replace the upper bound and the key value. else we pass binary search recursive method in which we pass mid plus 1 upper bound and key value. Let's see an example. If we want to find 12, then we pass 12 in key value. 12 in key value. And lower bound is 0, upper bound is equal to 8. If lower bound is equal to upper bound, no, lower bound is not equal to upper bound. And then we go to else. Mid is equal to lower bound plus upper bound divided by 2. Lower bound is 0. The upper bound is 8. We divide by 2. The result is 4. The mid is 4. Then we check the value we pass is equal to mid. No, we pass the value is 4 or 12 and the mid value at mid is 15. Then we skip this condition. If key is less than mid, yes, 12 is less than 15, then we recursive calling the binary search method in which we pass lower bound mid minus 1 key. The lower bound is 0. Mid minus 1, 4 minus 1 is 3. The 3 is become upper bound and this is cancel. And lower bound is equal to upper bound. No, lower is not equal to upper. Then we go to the condition else. Mid is equal to lower plus upper divided by 2. The lower is 0, upper is 3. The 0 plus 3 divided by 2 is equal to 1.5 and 0.5 is waste. Then the mid become 1. Mid become 1. If key value is less than mid, no, 12 is greater than 4, then we call recursive binary search mid plus 1 upper bound and key value. Mid plus 1, mid is lower bound is 0, mid plus 1, then 0 is replaced with 1, lower bound is in 1. Then we check lower bound is equal to upper bound. No, Lower bound is not equal to upper bound. Then we go to the else condition. Mid is equal to lower plus upper divided by 2. 1 plus the 2 is less than mid. No. Key value is greater than mid. Recursive calling binary search method mid plus 1. Lower is 1. Lower then mid plus 1 is 2. The lower is at 2. Then we check lower is equal to upper. No. Else mid plus 1 divided by 2. No. Lower plus upper divided by 2. 2 plus 3 divided by 2. 5 divided by 2. 2.5. The mid is at 2. Then we check key is less than mid. No. Key is greater than mid. Then we recursive calling mid plus 1, mid plus 2 plus 3 plus 1. The lower is at 2. Lower plus 1 mid. The lower is at 3 and the upper is also at 3. Then we check if lower is equal to upper. Yes, the lower is equal to upper. Then we check if lower is equal to key value. Yes, the value is at lower is 12 is also as key value. Then we return lower bound. Here is the output. The 12 is the output. Thank you. Please subscribe my channel. And I am the student of NFC IT CS department.